Hi everyone, it's Miss H, and today we're going to be looking at waves. Again, specifically we're going to be looking at wave properties and how to do calculations involving waves. So this is a continuation of our last video on identifying types of waves, and the next video will be on wave interactions. So looking at the properties of waves, there are four main properties we need to look at. The first is frequency. Frequency is how often something occurs. So when we're looking at waves, it's typically how many crests or how many troughs pass by a given point in a given amount of time. So this would be like standing out on your corner of your road and counting how many blue cars pass in 1 minute. That's kind of the idea of frequency. How often does it occur? So that would be the frequency of blue cars. But when we're talking about waves, we're usually looking at frequency of crests or frequency of troughs. How often does that pass by me? The variable for frequency is a lowercase f. It's important to remember that it is a lowercase f. Don't get that mixed up with a capital F on your reference table. The capital F is force. That's completely different. We want the lowercase f for frequency. And frequency is measured in hertz. So if you actually look at a radio that has like an actual dial on it, not just the, push the up or down button, you'll see that next to where it says the radio station number, it actually says HZ on the end, because what you're measuring when you're trying to get your radio station is actually the frequency that radio station comes in on. The next property is period. Period is the amount of time needed to complete one cycle, so the amount of time to go from the start of one wave to the start of the next wave. Since period is a type of time, we use a specialized version of the variable for time with a capital T. The unit for period is typically going to be seconds. It could be some other form of seconds like milliseconds or that sort of thing, but usually we're just going to stick with seconds because it makes it easier. It's also important to note that frequency and period have an inverse relationship, where that inverse means that when one goes up, the other goes down. So if I want to solve for frequency, I can do 1 over the period, and if I want to solve for the period, I can do 1 over the frequency. And that's not likely to come up on your exam, but it's something that you still need to know just in case. The next property we want to look at, we talked about a little bit in the last video, which is wavelength. So wavelength, as we said in the last video, is the distance from one like point to the next like point on the wave. Typically that's going to be crest to crest or trough to trough, but it could be the start of the wave to the next start of the wave. Anything that's the same one point to the next like point could be wavelength. The variable for wavelength is the lowercase Greek letter lambda, which looks kind of like an upside down Y. And the typical unit for wavelength is going to be meters, but again, it could be centimeters, millimeters, nanometers, kilometers, any form of meters. The last property we want to look at is wave velocity. So unlike the others, wave velocity is not typically directly measured, it's typically calculated. Wave velocity, similar to velocity in general, is how far it travels in a given amount of time. So wave velocity is how far the wave travels in a given amount of time. The variable for wave velocity is just a modified version of the variable for velocity. It is a lowercase v with a subscripted w to specify that we're looking at wave velocity, because our formula for wave velocity is a little bit different than our typical velocity formula. So again, wave velocity will normally be measured in meters per second, but it could be any distance unit over any time unit. We're just going to typically stick with meters per second. And the formula for wave velocity is the velocity of a wave is equal to the frequency times the wavelength. So if we put this into a triangle, wave velocity goes in the top, frequency and wavelength go in the bottom because they're multiplied together. We have to keep them multiplied together. So if we want to solve for frequency, we get wave velocity over wavelength, and if we want to solve for wavelength, we get wave velocity over frequency. If you want to figure out where this formula came from, we can actually kind of go back to the velocity formula. So velocity was distance over time, and so if we modify that, then wave velocity is wavelength over period, and 1 over period is frequency, so that's where the wave velocity is frequency times wavelength comes from. Not really that important, but just kind of something out there to help you kind of figure out where that formula came from. So let's practice using this formula, the one that we're actually going to use, on a couple of questions. So question number 1, what is the velocity of a wave with a frequency of 200 hertz and a length of 0.25 meters? So we're going to start with identification. So we're going to identify 200 hertz is a frequency, 0.25 meters is a wavelength, and we are asked to solve for the velocity of the wave. So that's V subscript W. Step 2, we write our formula. So VW equals frequency times wavelength. Step 3, we plug our numbers in. 200 hertz times 0.25 meters, and if we put that into the calculator, we get 50 meters per second. So 50 meters per second is the velocity of this wave. Number 2, what is the frequency of a wave with a 2.5 meter wave traveling at 50 meters per second? So again, we're going to start with identify for step 1. So we're going to identify 2.5 meters is our wavelength, 50 meters per second is our velocity, and we're being asked to solve for frequency. So step 2, I'm going to either use my triangle or rearrange my formula to solve for frequency. So frequency is velocity over wavelength. So that's going to be 50 meters per second over 2.5 meters. When I plug that into the calculator, I get a frequency of 20 hertz. So 20 hertz is the frequency of this wave. Last one, what is the wavelength of a wave traveling at 350 meters per second with a frequency of 125 hertz? So again, as we identify here, 350 meters per second is a velocity. 125 hertz is a frequency, and we're being asked to solve for wavelength. So again, step 2, we're going to either use our formula or our triangle to figure out our formula. So wavelength is velocity over frequency. So that's going to be 350 meters per second over 125 hertz. So 350 divided by 125 gives us a wavelength of 2.8 meters. 2.8 meters for the wavelength of this wave. So that's all of our properties of waves and calculations. Again, in the next video, we're going to be looking at wave interactions.